Hello. In this video we're going to learn how to solve absolute value equations. And we're going to start with very simple ones like this first one. We're going to move on to put more stuff inside the absolute values. We'll look at what happens when we have stuff outside the absolute values. And then we'll answer the question, do all absolute value equations have solutions? So let's get started. We'll take a very simple equation. The absolute value of x equals 5. Now, we can split that into two possibilities. If we take the absolute value of 5, that will give you 5. Or if we take the absolute value of -5, that will also give you 5. So we have two solutions. X could be 5 or x could be -5. And we can graph the solutions on a number line as follows. X equals 5 is here, x equals -5 is there, and there you go. Okay, so let's take a look at absolute value of x equals 7. I'd like you to do exactly the same thing with the absolute value of x equals 7. Stop the video, do the work in your journal, then we'll take a look at it. Okay, so here's what it should look like. X equals 7 and x equals -7. And the graph should look something like this. This is 0, 5, and 7, and dot at 7, and 0, -5, and -7, dot at -7. So that's what your graph should look like. All right, now we're going to take a look at what happens when we have something inside the absolute value. Now, just as we did before, we're going to split this problem into two problems. One of them is going to be that x minus 3 equals 10, and then we're going to look at x minus 3 equals -10. Now these are fairly easy to solve, so I won't go through all the steps. Just add 3 to each side and you get x equals 13. Add 3 to each side and you get x equals -7. You have to be a little careful of your signs over here. Then the graph will look something like this. Okay, there's a graph of x being 13 and -7, and it's always a good idea to check your answers just to be sure that they're correct. So we can substitute 13 for x in this equation. We have absolute value of 13 minus 3 equals the absolute value of 10, which is 10, and that's correct. And then we'll test the solution -7. So we'll put -7 in for x. -7 minus 3, absolute value, is equal to the absolute value of -10, which also equals 10. Now, I'd like to take a look at one more that's got a little more going on inside the absolute values. As before, we'll split this into two problems. 2x plus 10 could equal 14, or 2x plus 10 could equal -14. Here, on the left-hand side, you're going to subtract 10 from each side, divide by 2 to get x equals 2. And on this side, you're going to subtract 10 from each side, get 2x equals -24, and then divide each side by 2 and get x equals -12. Now, the next thing to do is to graph the solution, and this is what the graph should look like. This should be a point at -12 and a point at 2. All right, so that's what we have. And down here, we check the solutions. 2 times 2 plus 10, absolute value, is equal to the absolute value of 4 plus 10, which equals 14. That's correct. And here, the absolute value of 2 times -12 plus 10 is equal to the absolute value of -24 plus 10, which is equal to the absolute value of -14, which does equal 14, so we're good. Now I'd like you to try each one of these absolute value equations. Copy them into your journal, stop the video while you do them. Be sure to solve them, graph them, and check your answers. And when you restart the video, I'll show you the solutions. Okay, I'll show you the solutions here. To the first two, I'll look through them briefly. we split this first problem into x plus 2 equals 5, x plus 2 equals negative 5. We solve by subtracting 2 from each side. We get x equals 3, x equals negative 7. Here's the graph, and there's the check. On this one, we split this problem, the absolute value of negative 4x equals 20, into negative 4x equals 20 and negative 4x equals negative 20. We divide each side by negative 4, getting x equals negative 5 here, x equals 5 here. There are solutions, and here's the check. And here's the third problem. 5y minus 7 absolute value equals 33. We split this into 5y minus 7 equals 33 and 5y minus 7 equals negative 33. Add 7 to both sides. Divide each side by 5, and we get y equals 8, and y equals negative 26 fifths. This is what the number line graph looks like. And we'll check the solutions. First, we'll substitute negative 26 fifths for x, for y rather. And we'll take 5 times negative 26 fifths minus 7 equals, well, 5 times negative 26 fifths is just negative 26 minus 7. That's the absolute value of negative 33. That equals 33, and we're good. Here, for the other solution, we substitute 8 for y. 5 times 8 minus 7, absolute value, equals the absolute value of 40 minus 7, which does equal 33. Now we're going to take a look at what happens when we have stuff on the outside of the absolute value. So let's split this problem up the way we did before. Don't put this in your journal just yet. Just watch. So we're going to take the absolute value of x plus 3 equals 10, and we're going to split it into x plus 3 equals 10 and x plus 3 equals negative 10. We'll subtract 3 from each side. And on this side we'll get x equals 7, and on this side we'll get x equals negative 13. Now let's check our answers. So if we substitute 7 for x, we'll get absolute value of 7. That's 7 plus 3 equals 10, and that's correct. Over here, if we substitute negative 13 for x, we get negative 13 absolute value plus 3 equals 10, or 13 plus 10, plus 3 rather, but that doesn't equal 10. So negative 13 is not a correct solution. And that is because we did this the wrong way. Next, we're going to learn how to do these the right way. So you can put this into your journal. When we have a problem where there is something inside the absolute value and something outside, our first solving step is going to be to isolate the absolute value. In this case, what that would mean is we subtract 3 from each side and get this new absolute value equation, the absolute value of x equals 7. So we split that into x equals 7 and x equals negative 7. And then we draw our absolute value graph here. The solutions are 7 and negative 7. And we can see in this equation that if we substitute 7 for x, we'll get absolute value of 7. That's 7 plus 3 equals 10. And if we substitute negative 7 for x, we will get negative 7 absolute value, which is 7 plus 3 also equals 10. So this is the correct solution. And the key to doing things the right way is to isolate the absolute value before we split up the problem. Okay, so that's the key. Let's take a look at some problems that you can do now. I'd like you to try these two problems first, copy them into your journal, stop the video, solve them, and then we'll take a look at the solutions. I'll go through only the critical parts of the solutions slowly, and then the rest of them I'll just kind of show you, and you can check your answers and stop the video if you need to. Alright, so in this first problem, the key step is to isolate the absolute value, add 5 to each side, and get the new problem, x plus 3 absolute value equals 32, and then go ahead and solve the rest. Solutions are 29 and negative 35, and this is what they look like graphed, and I'll leave it to you to check the solutions. For the second problem, again, the key step is to add 3 to each side to isolate the absolute value, and you get the new equation, 2x plus 1 absolute value equals 14. And then you split and solve and graph just as you did before. And once again, I'll leave you to check those answers. Now the last question is, do all of these problems have solutions? If we take a look at this problem, x plus 3 absolute value plus 10 equals 5, well, let's just do our normal solving step. So the first thing we would do is subtract 10 from each side. And what we get is the absolute value of x plus 3 equals negative 5. Now, this should be a red flag to you right here, because the absolute value of something can never be negative. So this means that this has no solution. But let's say that we didn't notice that, and we continued to go on solving. So first we do the rest of the math, and we get the solutions x equals negative 8 and x equals 2. And then we check the solutions, and we'd see that neither of them work. And this problem shows one reason why it's always important to check your answers after you solve an absolute value problem.